inclined to all the reference planes. So we know that reference planes, horizontal plane, vertical plane and profile plane. So the oblique line is that line which is inclined to both the reference planes or all the reference planes. So this line will not show its true length in any view. So it is very essential to draw or find out their true length. So before going to see that oblique line, we have to start the basic some lines and their projections and how they will show their true lengths in one of the planes. So out of that, the first line is a line parallel to both the planes. Suppose one line is there which is parallel to both the planes. Now, what are the front view and top view of this line? So you see, their views, if we draw a reference line, so what is about this reference line? We call this line as an intersecting line of vertical plane and horizontal plane. So above this line, the vertical or frontal plane is there, and below this line, horizontal plane is there. So we have taken the first line, the line which is parallel to both the planes. So their views are as like this. If we call it as AF, we call it as a BF, because we have taken the AB line which is parallel to both the planes. Now their front view is this. Corresponding top view, so you project this A and B points and you draw another line here in this top view, in this plane. It is called as the AH and BH. Now you remove this projectors and that way. So this is the true length and this will also the true length of the line. So what happens? You keep in mind that if line is parallel to one of the plane, the line will show its true length on that plane. Once again I repeat, if the line is parallel to one of the plane, then that line will show its true length on that plane. Now in this first case, line is parallel to both the planes. So that's why it will show its true length in both views. Or you keep in mind that if a view of line is parallel to reference line in one view, then their next view is definitely true length. So you see this view of this line is parallel to reference line, so this is the true length. If view of line is parallel to this line, this reference line, then this is the true length. So these are the views of line which is parallel to both the planes. Now, next line. So these are the views of this line. Now, next line is a line parallel to one plane and perpendicular to other plane. Now you see that. What is the line? Line is parallel to one plane, perpendicular to other plane. So what are their views? Suppose a line is parallel to vertical plane and perpendicular to horizontal plane. What are their views? So as usual you take the reference line, then it is a FH. So this line is parallel to vertical plane. So this is the ABF and corresponding their top view is H and BH. So these are the views of the line. So what happens? What I told you that if line is a parallel to vertical plane and perpendicular to horizontal plane, then their views are this. So this is also true length. This is also true length. And you see that why is it true length? Already I have told you that if line is parallel to any plane, then that line will show its true length on that plane. So here we have taken the line is parallel to vertical plane. So that's why it will show its true length on vertical plane. This line is perpendicular to horizontal plane. So if a line is perpendicular to any plane, that line will show its point view on that plane. So it is called as a point view of the line. It is called as a point view line and this is the true line. Okay. Now what is this solution? Here the question is that the line is parallel to HP, VP and perpendicular to HP. So these are their views. Next, if now I can take the opposite. If line is parallel to VP and if line is parallel to HP and perpendicular to VP, exactly opposite to the previous line. Line is parallel to HP and perpendicular to VP. Then what are their views? Their views are as usual reference plane. Here it will show this two line. Two lines of line. AH, BH, and on the same projector here we observe the AF, BF. Isn't it? So this is a two line and this is a point view of line. So once again keep in mind, I told you that if line is parallel to one of the reference plane, the line will show its plane on that plane. Isn't it? And if line is perpendicular to one of the plane, the line will show its plane point view on that plane. Okay? So previous line is parallel to VP, perpendicular to HP. Here line is parallel to HP, perpendicular to VP. So these are the views of the lines. So up till now we have seen three types of lines. What are they? Line is parallel to both the planes. Line is parallel to vertical plane, perpendicular to horizontal plane. Line is parallel to horizontal plane, perpendicular to vertical plane. Now, fourth type of line. Line is inclined to one of the plane. Line is inclined to one of the plane and parallel to other plane. Line inclined to one of the plane, parallel to other plane. Okay? What are their views? As usual, take the reference plane. Okay. Now suppose a line of 50 mm length is parallel to VP and inclined 40 degree to HP. Once again listen. A line parallel to VP and 50 mm long and inclined 40 degree to HP. Complete their projections. So solution of this is you take any point here, you draw this. This is a F, this is a BF, and you project this point and you directly draw a line here. So that is the H, this is the BH. Here, this is the angle theta, this is a true line, and this is a TVL, top view length, not a true line. It is a TVL, top view length, not a true line, and here it is a true line, and this is the angle. So what is about this theta angle? Angle made by line with HP. Okay, so what is the given? True line 50 mm, theta 40 degree. And to start the problem, we have to give the position of this point A. So this we studied in projection of point. So in projection of point, how to locate the points we have studied. Suppose here point A is given. Point A is given. A is given as 15 mm above HP and 10 mm from feet. parallel to VP and inclined to HP. So this is the line which is given. Now you see, line is parallel to VP. Already I told you that. If line is parallel to one of the reference plane, that line will show its straight on that plane. So line is parallel to VP, it will show its straight on VP. And the profile is parallel to reference line, and it is not a plane but it is a apparent plane. We call it as a TVL, top view line. What is called TVL? Top view length of line. Okay? And now this theta we observed in front view, because that line will make somewhat angle with HP. That is given here in the 40. So this angle is an angle made by line with HP. So angle made by line with HP is observed in front view. Okay? So this is something about this fourth type of line. Now exactly opposite to this, fifth type of line. Okay? Now you see that fifth type of line parallel to HP and inclined to VP. Line 50 mm long, A 10 mm above HP, 15 mm in front of PP, and line length 45 degree to PP. So now this is the fifth type of line, and that line is parallel to HP, inclined to VP, line to length 50 mm. Point A is given 10 mm above HP, 15 mm in front of VP, and line length 40 degree to VP. Now this line is parallel to HP and inclined to VP. What is about the previous line? Previous line was parallel to VP, inclined to HP. Here exactly opposite. So how this you can find out the angle of this line or use of the line here. First we take this point A, 10 mm above HP. 10 mm above HP. This is the area, and 15 mm in front of VP. This is the edge. Okay? Now the first information we have taken. Second we have to take, as in last case, line was inclined to HP, that angle is observed in front view. Now this line makes 45 degree to VP. So this angle is observed in top view. So here we can take an angle of 45 degree. Angle made by line with VP is observed in top view. Isn't it? Now, at 45 degree we have drawn this line. What is about this line? This line is a direction of length of line. So, to length is given 50 mm. At 50 mm mark on this, it will give us the BH. Now you draw this projector and directly draw this line. Where it meets, that is the BH. Now here, this is called as a to length of line, and this is called as a FVI. You see, last time, to length in front view, TVL was there. Here, 45 degree to VP, that angle is observed in top view. There we can draw the direction of the line. There we have taken it to length and directly draw the projector and draw the horizontal projection. This completes the projection. This is a clear true line, and this is a FVL for front view length of line. FVL for front view length of line. Okay? So this is the fifth type of line. Now next sixth type of line. Line is parallel to one arm and it is on that line. For example, if line is parallel to VP and it is on VP, complete their projections. What is the next type of line, sixth type of line? The line is parallel to VP and on. So how the projection changes you see? As like the fourth type of line. What is the fourth type of line? Line is parallel to VP, inclined to HP. In the same way, this line is parallel to VP, but it is on HP and inclined to, also on VP and inclined to HP. So what are the views? So you see that. As you know, suppose the line AB is given, it is parallel to VP, on VP, inclined 40 degree to HP, the length is 50 mm and the end is 10 mm from both the planes. So how we can draw the projections? So what are the informations given now? You see that the information given first, line AB, A 10 mm from both the plane. 10 mm from both the plane. Then length of line is given, that is supposed to be clear. Theta is the angle made by line which is given, that is 40 degree. Okay? And here it is asked to complete the projection. So first we take this A point. So A is 10 mm from both the planes. Here F, here F. This is 10, this is also 10 mm from both the planes. Now we have to take this angle. Angle made by line with HP is observed in front view. So we have to take that angle in front view. So here is line. What is about this line? 40 degree. Angle made by line with HP. So the line which is drawn at 40 degree is nothing but the direction of true length of line. Isn't it? Now the true length of line is given. So that true length is marked here. Suppose this is the BO. This is the true length which is the 50 mm. So this is the front view of this line. Now similarly we have to draw the projection. Okay? And if you join this, now this line is on HP. This line is on HP. So that B point, BF will come here, and here we have to join. This is the, BH, AH and BH. Now why we have taken this? Suppose this 10 mm? No. What is the difference? That line is on HP. When that line is on VP, that their top view will come on the reference line. Okay? So this is AH, this is BH. Now this is today. Here it is called as a TV. Here it is called as a TV. Okay? So what is about this problem? When line is on VP and parallel to VP, then their front view and top view come in this line. Now next type of line exactly opposite to this. What is the next type of line? Exactly opposite to this. What is about that line? That line is parallel to HP and on HP. Line is parallel to HP and on HP. Line is parallel to HP and on HP and inclines more degree with VP. So their projections have to take this line H, BH and F and BF. So judge this. This is the BF. Now this is the phi. What is the phi? Phi is the angle made by line. Angle made by line with phi p. Phi. So where it is observed? In top. And this is the true line. This is F sphere and it will come on the reference line. Okay. So these are some 8 type of simple lines we observe. Now next type of line is an oblique line, and we see what are the views of the oblique line. And because up till now we have seen all the 8 types of lines show their true line in one of the views, either in top